Thank you, guys. I appreciate everyone rallying. It's pretty late in the second day, so thank you for being here. So my name's Mike, and my talk is called Evidence Over Advice, Learning Programming Faster Using the Scientific Method. And I just want to apologize. I have a little bit of a cough. I've been battling it all conference, so if I need to stop and take a drink, I'm just going to do that. So, okay, so I have had this thought many times in the course of my professional career. Probably hundreds of times. I wonder if that's actually true. And, as developers, we're constantly bombarded by all kinds of information from blog posts, from YouTube videos, PR comments, our mentors, just like lots of different ideas and information, some of it conflicting. It's hard to know sometimes like what to trust, right? And so, some people deal with this by kind of like eroding that feeling of just, stop, like just trust what the experts say, right? I want to propose a better way of doing it. So this is a feeling that I pay attention to a lot, and it can, this feeling of skepticism. And I kind of want to propose like a mental model and like a framework for how to actually act on that and how to actually turn this skepticism into knowledge, right? Something that you can actually see and like experience for yourself. And the way to do that is using experimentation. And that's through the scientific method. So spoiler alert, scientific method. So I'll get to that. But first, I want to tell you a little bit about myself. I'm Mike, staff software engineer at Rippling. I've been doing this for about 15 years. I currently live in Seattle with my wife and my 2 kids. I like music. I play guitar and piano, and I sing. I like video games, and I do close-up card magic. So if anyone wants to see some card tricks out in the hall after this, feel free to come hit me up. Okay, back to the talk. So this is a situation I found myself in just last month, where this is an actual screenshot of a code review. And this is React, by the way. I'm going to try to keep the React talk like a little bit minimized, but I can't help myself a little bit. There's a lot of confusion with React. So this is React. This teammate is proposing using use memo on this column config declaration to basically not render a new array every time the React component renders, even if it's not required. And so I'll take a quick detour to talk about what use memo does. So what is use memo? It's a React hook that lets you cache the result of a calculation between renders. And React is renders a lot. Like every component renders a lot, like hundreds of times, maybe thousands of times over the course of an application's lifetime. And when these renders can be expensive, they can be cheap. Like usually a render is pretty cheap, but sometimes you can do something expensive in the course of a render. And you don't necessarily want to do that every single time. So sorting a big array, doing something computationally expensive, right? Like doing some math, right? So React uses this hook called use memo to basically record the result of that calculation. So the next time it can just reuse that result. That's what memoization does, and that's what use memo is. So just a quick diagram. We have some inputs. It goes into use memo, and then we test whether the inputs have changed. If they have not, then we use the cache result. Otherwise, we recompute the result and we update the cache. So kind of going back to this example, this is not a very expensive operation. He's proposing that we cache this result using use memo. It's just an array declarations, and array declarations are cheap. And so I was just sitting there thinking, like, what are we even doing here? Like, why, what is the point of this comment? And now this person has to go and update their code and trigger another 2-hour build to get this use memo in, but it's probably not even helping performance, right? And so there's been this debate ever since use memo was created. And over there on the left, you see the React docs where you should use memo as a performance optimization. And on the right, you have kind of thought leaders like Ken Dodds and Josh Comeau saying, don't overuse use memo. It's a performance optimization. You should use it judiciously. Ken Dodds has a really good quote where performance optimizations are not free. They always come with a cost, but do not always come with a benefit. And just I'll caveat this, like React doesn't say use memo everywhere. There are some people who clearly have taken that message and said we should use memo everywhere, right? And so React docs explicitly even say like, when should you use memo? They talk about using it judiciously, but some people have interpreted use memo as we should be using it everywhere where we could conceivably get any kind of performance benefit. And so what do you do with this information, right? I think it's like pretty safe to trust Ken and Josh. They know their stuff. But I kind of want to propose like a different method. So the real question is it's not even about use memo. It's not about even performance, but it's about intuition, right? So how do we develop an intuition about performance? Not just, again, I don't want to over-index on the use memo thing, but I will use an example. But just zooming out, like how do we develop our intuition about programming? So let's go back to high school. So this is, everyone has probably learned this in their biology class. The scientific method, the cornerstone of human knowledge in the past like several centuries. Ask a question, gather information, form a hypothesis, run an experiment, analyze the data, and draw a conclusion, right? That's the scientific method. It is how we empirically develop our knowledge based on observation, not just by trusting thought leaders or kind of like thinking our way into theory and like coming up with the answers that way. You can kind of like tangibly see the results of reality. And so I've kind of distilled this down into 4 steps. Predict. What do I think will happen? Run, execute the experiment, result what actually happened, and takeaways. What did I learn? And so I will talk a little bit about each of these steps, and I'll show you some examples a little bit later. I want to talk a little bit about why I think this method is so effective too. So in addition to kind of like arming you with a lot of confidence in the way that you engage with other people about your knowledge, again, like I think the argument is a lot weaker when you say, hey, some X thought leader said we should do this versus like, I tested this, right? I tested this and I can see that we should do this, right? So that's one benefit. But I think the even bigger benefit is that we learn a lot better when we are actively learning, right? And so, on the left, we have someone reading blog posts, someone watching YouTube videos, right? They're passively learning. They're kind of engaging with the content, maybe a little bit more than surface level by taking notes, but it's still pretty passive versus, and like that kind of knowledge, I think is like easily lost. And versus like actively kind of like thinking through what kind of experiment would prove this, right? And sitting down and writing code. And then at the very end, looking at the result, right? And tangibly seeing the result and like gaining knowledge that way. And so I really think that this has like played a huge role in my ability to retain information throughout the years. So I know what, I think a common objection is like, oh man, I have to experiment with like everything I learned. No, I don't think so. I think like, we're all busy people. You have a job to do. And so I've kind of developed these triggers as to when it makes sense to experiment. So the first one, and it's 3 C's. The first one is controversy. If you start to see different thought leaders disagreeing on certain things, I think that's a good time to kind of like test things for yourself. Confusion, weird bugs that make no sense. And I have kind of like examples of each of these, and I'll show you what those look like. And then curiosity to see if like new tech lives up to the new hype. And the underlying thread to all these, I think, is they resist Googling, right? So controversy, if you Google it, you're going to see the different results from different people. You're not going to really know what to believe. Confusion is like sometimes you don't even know what question to ask, right? Like if you're super confused about something. And curiosity, like if it's like brand new, then there might not even be anyone writing about that yet, and you might be the first one, right? So if you go out and do that experimentation yourself. Cool. Any questions? I'm going to get into the demos. Cool. All right. So demo number 1 is around controversy. When do you use memo? So I have kind of like this is a very, very bare bones way of measuring performance. If you look at this slide, basically like, starting at the top, you got this number of iterations. So you usually have to set this to a pretty high number, at least in the thousands, tens of thousands sometimes millions, in order to see the result, like an appreciable difference, right? If you're testing sorting 1,000 items in an array, that's going to take like nanoseconds, right? So you have to kind of do that over the course of like many, many iterations in order to see a difference between the memoization version and the non-memoization version, right? So so testing without the memoization, like this is like non-React land. I have another slide for React land. So basically we have this like start without, and that basically starts a stopwatch. And then you run this expensive operation X number of times, stop the stopwatch, right? And you record that time. Then you have the cache version where you start the stopwatch, and then if you've cached it already, you don't run that operation again. Then you start the stopwatch, and then at the bottom, you compare the two, right? Very, very simple method of like doing some benchmarking. And so, like I think this is like probably like the absolute simplest way that you could do some benchmarking to see the performance impact of an optimization. And so there's a little bit of creativity involved in the React version, because what we're testing is renders, right? And how long it takes to do some rendering. And so what I have here is this parent component that has a count variable, and we pass the count variable into a child. And so every time you increment the count variable, the child will re-render, right? And so in that sense, you can kind of test the clock time that it takes to re-render a component 10,000 times, right? And so we have this child without memoization, and then this child with memoization. And so in the with memoization version, we're obviously using use memo. Any questions about that? I know I kind of ran through that quickly. Cool. All right. So I'll just do a live demo real quick. And so I've kind of created these test harnesses. Can everyone see the text okay? Okay. Cool. So I have these different ways. Oh my God, where are all the borders? It's fine. Okay, so I have these 6 different scenarios, right, where we kind of like test different operations that you can do within a use memo version and a non-use memo version, right? So this one is just a math problem, right? This one is a person object creation problem, right? Sorry, not a problem. It's like creating an array with a bunch of properties, right? This one is sorting an array. This one is sorting a bigger array, right? This one is doing like a chain filter and like map and like something that you'd kind of expect to do in like a real app if you're doing some array manipulation. This last one is calculating the Fibonacci number. Like this is just like you don't need to know too many details about what if you do lead code, you know what Fibonacci is. But like if you don't know what it is, it's just something very computationally expensive. You do some recursive calls to calculate a number, and the higher up you go, like it gets really, really expensive to do. Sometimes it takes like multiple seconds, even if like math problems usually don't take that long. So I'm going to just run through all these tests, and you'll see the results. Cool. All right. So you can see that so first of all, like I was surprised that use memo wins in every circumstance. I thought that there would be some circumstances where use memo is slower, just based on like what Kent C. Dodds and Josh Como were saying. I will caveat that like this doesn't test memory. Memory is like much harder to benchmark, so I couldn't get that done in time for this conference. But you can see that like there are cases where the difference is almost zero, right? It's like very close to zero. There's some cases like this large array of sort where the difference is like very substantial, right? So 90% reduction in how long sorting this array 10,000 times takes. Same thing for calculating the Fibonacci number, right? So all that's to say, like, and so, kind of going down to this like trivial thing, I'm not trying to like just twist the data to my own narrative, but this is really like trivial if you consider the fact that like you're dividing each iteration by 10,000 times, right? And so if the difference is like 50 milliseconds, you divide that 10,000, you're like talking nanoseconds, right? And so that is like never going to make any kind of difference in any kind of real performance impact, right? But it might make a difference in terms of memory, right? And it also makes a difference in terms of like readability of your code, complexity. And so my conclusion from this is that there are definitely situations where use memo doesn't make sense, right? And this object creation, like going back to the original PR, is one of them. I don't think that it makes a big enough difference in that case. So So this is my summary of my conclusions. I predicted that use memo would be faster in heavy computations, slower in light. The result was that use memo was faster in all cases, but it was negligible in some of them. And my takeaway is that Ken and Josh were right. You shouldn't use it all the time. Demo number 2, confusion. So this is a actual story from my career. Like, these are all actual stories from my career. I was doing something like this. AKA what the F is a microtask. So the case of the missing spinner. So I was doing something like this in React, and again, I apologize for anyone who doesn't use React. But the demo will actually take place in Node, but I'm just setting the stage in React because this is how I discovered this thing. So I was setting loading to true, and I was using the loading state to display a spinner, and then I would run a task and then set loading to false. It's pretty cookie cutter stuff that everyone's done at some point, right? So I would expect to see the spinner while the task is being performed, and that was not happening, right? And so I'll go to this spinner demo. So we have 2 versions of this. Promise chain, right? Where I click the button and there's supposed to be a spinner down here and there is no spinner. And then I click on here, this set timeout version has a spinner. So when we basically refactored, like I was just testing and I refactored the perform task to use a set timeout instead of a promise, I would see the spinner. What's going on here, right? This is something that, like, again, resist Googling. I wasn't really sure how to Google this. And so I was basically running an experiment in Node and trying to see, like, what is the result of something like this, right? And so quiz time. I'm curious if anyone knows the answer to this. What will this output? What order will these console.logs output? So option number 1, sync promise set timeout. Option number 2, sync set timeout promise. Option number 3, set timeout promise sync. I'm gonna, number 1, who thinks it's number 1? Right? Show of hands. Number 2, sync set timeout promise. And number 3, set timeouts promise sync. Cool. A lot of no hands. I respect it. I would have no idea if I didn't run this experiment myself. All right, so I'm gonna go and okay, so here is the script that I wrote for this. Again, this is exactly what you just saw on the slide. I'm gonna run this and we'll see what the result is. Sync, promise, set timeout. So good job to everyone who voted 1. So yeah, that is pretty confusing. It was pretty confusing when I was, like, looking at this. And sorry, I'm trying to find the slideshow again. Where is it? Okay. So yeah, then you can go even deeper, right? You can kind of, like, run these in a loop and interleave them. And so I'm gonna just jump to the conclusion real quick that promises always run before set timeouts. So promises are running, like this experiment helped me, like, realize that, and then, like, do a little bit more Googling. I found, like, a Jake Archibald article about microtasks, and promises always run before set timeouts. And so you have to kind of be mindful of when you're using these things to avoid things like UI freezing, React rendering, jank, all kinds of, like, other issues. And I'll just show you what this looks like. So, you know, the call stack, you have the call stack, and then after that, any microtasks that are queued, these are promises and a newer function called queue microtask. And then after that, it's set timeout, set interval. And then only after that is, like, request animation frame and paint. And so, yeah, this is something I learned from experimenting, and I got to see with my own eyes. And I can do the deeper dive as well. Where basically I have these functions running, like, interleaved in a loop, and you can see that they always get grouped up. So next tick, always, all the next ticks run, all the promises run, all the set immediates run, and then all set timeouts run. So this was a pretty surprising result that I had. Cool. All right. And demo number 3, curiosity. So I have been in the field long enough that I was here before web workers were a thing. Web workers are a thing now. But I remember when they were first coming out, I was like, oh, this is really cool. And I like did a little experiment with them to kind of figure out. And like obviously these aren't the original experiments I designed, but I kind of recreated them for the purpose of this talk. But so this is the experiment I designed. This is like without web workers. There's Fibonacci number again. Did kind of like the stopwatch thing where we start the stopwatch and then we calculate Fibonacci, the 40-second Fibonacci number, and then we stop the stopwatch. Then we have with web workers. And sorry, web workers, for those who aren't familiar, lets you offload any work from the main thread to a background task, right? So the main thread of JavaScript is like everything that's required to interact with the browser, right? That's like like if something's running in the main thread and conflicting, then you can't do things like highlight text. You can't do things like click buttons, right? The browser is, for all intents and purposes, completely locked up, right? And so web workers let you offload that work. So if you have some CPU intensive tasks, like calculating the Fibonacci number, but more realistically, real tasks like image processing or like parsing like a huge CSV, right? Those are like real tasks that like could run in the CPU in the main thread and block everything. But this allows you to kind of offload that work. And so I wanted to basically see what that would look like if I offloaded that work. And so with web workers, this is what it looks like. You basically send a message to your worker to say, I want to process the 47-second Fibonacci number 10,000 times, right? Or 100,000 times. I don't remember how many times I did it in that experiment, but this is the main idea. The web worker runs in a background thread. It takes the number, it calculates it, the 40-second number a bunch of times, and then it sends it back to the main thread where you can kind of see the result. And so I'll show you what the live demo looks like. So this is a worker demo. So I'm going to show you, this is a 40-second Fibonacci. I think it takes like 4 seconds. And while I'm clicking on it, right, notice that my cursor is stuck in like your browser is like completely useless when it's running on the main thread, right? I'm like trying to highlight text, blah, blah, blah. I can't do anything. And then in the web worker version, you click on this and you see the spinner. Like, oh, by the way, this is what it's supposed to look like. It's supposed to have the spinner. It's supposed to like this elapsed number is supposed to change. But in the non-web worker version, nothing's happening, right? So web workers are like amazing for offloading this. And now I know because I've seen it with my own eyes that they're really good for this kind of thing. So my prediction, web workers help performance perception by offloading work from the main thread. They do exactly what they promised. They do increase the complexity, so you shouldn't use them all the time, but you should consider them for heavy computation tasks like image processing. So I kind of went on this whirlwind tour, and you might be like, "Wow, those are really random ideas, Mike. Like, why did you? What is the point of all that?" Like, I actually intentionally made them kind of like all over the map, because my goal is not to teach you about web workers. My goal is not to teach you about use memo. My goal is to kind of encourage you to have the experimental mindset, right? So like these are all the different types of use cases that you could do some experiments for. But I just want to encourage you to basically think like, what could I run my own experiments for, and to help me kind of cement my knowledge. And so I kind of want you to go from passively consuming to actively participating in your own knowledge growth. And so I've devised a couple of starter experiments, right? Like, can you test the performance impact of for each versus for of? Or inner HTML versus like creating 10,000 elements using inner HTML versus create element, or concatenating stuff using templating strings, or concatenation. And I just want to be clear, like, do not go and get in an argument with your teammates about this stuff. Like, all the performance impacts of this are going to be like completely negligible. This is just like encourage you to like think through like, oh, this is like, just to get in the habit of doing some experimentation for yourself and seeing the results for yourself. And that is it. Happy experimenting. Thank you for your time. I have time for like one question, if anyone has it, but otherwise I can just see you out in the hallway. Elder. So the question was, have I ever run in a situation where I've run into additional confusion from, is that right? Oh, interesting. Yeah. I mean, I would say that like this use memo thing was an example of it. Like it didn't conflict with like a previous experiment I'd done. But in my head, I've carried like, oh, the idea that memoization should lead to performance impacts, right? Or performance benefits, right? And so, that is something that I've kind of like retrofitted my own understanding for and like kind of brought that back to yeah, like it's usually I think like a lot of times when I'm doing these like controversy experiments, I'm often correcting a misunderstanding that I've had before. I did post the results of my experiment in the thread, but I still got overruled. They're fine. Like it's fine. Like sometimes it's like the case where the team just needs to like keep the styling consistent and stuff like that. So is get it. Yeah. Yeah. Cool. Thank you so much.